Okay. So we're doing 11.8 radical equations. All right, 11.8 radical equations. All right, step 1. You are going to isolate the radical. On one side of the equation. Basically, it's what you're doing is isolating the variable. Kind of like what we do with intruder alert. So it's the same thing, but you're, instead of isolating the X or the Y, getting it all by itself, you're going to be getting the radical all by itself. Step 2. After you have isolated, this is first. And that's what, the only thing that 7th grade right now is kind of struggling with is they keep forgetting that you have to do this first and then you move to step 2. They want to keep doing step 2 and then do this. And it doesn't work that way. So the first thing you do is basically intruder alert to get the radical all by itself on one side of the equal sign. Okay? Then step 2, you square both sides of the equation to get rid of radical, which y'all have done already. Y'all learned how to do that. I know 7th grade has. I'm going to tell Bob that it's getting a little bit louder.
At the end of the year, we're just going to be here and it's just going to be...
Another function. There's like a fan too.
I think it has to have a fan.
I know, but if you open it up,
One
Okay.
component to fill out. Is that
For example, if we want to remove that radical, what do? How do we get rid of the radical sign? Square it. And what does that become? Square root of what? Square root of 9, which then is 3. Okay, so basically, to get rid of the radical, you're going to square it, and then it becomes basically the radicand. You notice that? We've talked about that. These are the steps. This is the explanation of what we're doing.
so you just do that.
But yeah, so inevitably, all you do is square it, and it becomes 3 all by itself. Does that make sense? So to get rid of the radical sign, you must square it, and then it becomes the radicand. Do y'all have any questions on this? Does that make sense? Right here, we square it, so 3 times 3 is 9. Square root of 9 is 3. But if you understand this, then you can just go right to the radicand. Let's show another one. Let's say I have 5 plus x all under, now handwriting is going to be important here. If I have 5 plus x all under the radical sign, to get rid of it, we square it. Technically, that would become 25 plus x squared, correct? Which then becomes 5 plus x. Right? Because 5 times 5 is 25 and x times x is x squared. Or you can just learn that when you square whatever's under the radical sign, the radicand, it just becomes your answer.
Is that as long as it's square root, not like the cube root?
Correct. But even then, I mean,
Well, you just.
it would still, yeah, it would still work as long as it's, the root is 3.
Now, if the root wasn't 3.
Right, then it would be
that
different.
You have to actually multiply and factor.
Right. Okay, let me show you another. We would square that. And Emily, what would that become? What's the final answer?
14.
Yeah. Exactly. Not a trick question. So that's how you get rid of the radical. You square, but you're going to square both sides of the equation. And then the last step, 3, you're going to solve.
I like that stuff.
All right. Now, a little bit of information here. 3 stars. A radical can't equal a negative. A radical can't equal a negative. For example, I'll let y'all look at this. If you isolate, now listen to what I'm saying. If you isolated the radical, and this is what you get. Okay, here's the radical all by itself, equals -4. If the, now listen to what I'm saying. If this is isolated already, like it is now, it cannot equal a negative. So if you've done, and I'm going to show you more examples. Okay, so the answer would be no solution. That's really the only rule.
Will there be no solutions on the test?
Quite possibly, yes. Because that's kind of an important rule. And I got to make sure you understand it.
Is it only if it equals it?
If you have isolated the radical, you don't even have to continue working it. You don't even have to square both sides
Yeah.
because it won't work. If you have isolated the radical, and I'm going to give you examples. So you have the radical on one side equals a negative, it's no solution. You don't even have to, in fact, a lot of my students in the past have enjoyed those because they don't have to do all the work. They don't have to square both sides and start working it. It's done.
Yeah.
So it's no solution. If you have radical by itself on one side and a negative on the other, it is a no solution. Does everyone have this? Let's start doing examples. All right, here's one. (2x plus 5), and it's under the radical sign, equals 8. Okay, first of all, handwriting is very, very important, and I will take off if you sit there and you write something like this. And you're too lazy, to continue that line over there, I will mark it wrong. Okay? And you will probably mess up because that's a whole nother thing. Then you would move the 5 over and then take out the radical. So you got to make sure you write it carefully. Okay, step 1. Isolate radical. Is this radical all by itself on this side of the equal sign? Is it right now?
Yes.
Yes, it is all by itself. I'm going to put that all by itself. So yes, it is. So step 1 is correct. We've done it, or it's already done for us. Step 2, we then square both sides. Real quickly, is 8 negative? So therefore we can continue. So I'm going to square both sides. Okay, so step 2 is square both sides because we got to get the 2x plus 5 out of the radical sign. So then we're left with 2x plus 5 with no more radical sign equals 64. So I'm going to stop there. Make sure you have this written down. And does anyone have any questions before I move on? Any questions? Cecilia, any questions? Michael? Michaela? Emily? Taylor? All right. Step 3, we solve. So this is, now that we have the radical all by itself, we square both sides. Now we do intruder alert. So let's see, Aiden, what do I do first?
Minus 5.
Yep. 2x equals 59. Now what do? Divide both sides by 2. Stuff y'all know how to do. Now in this case, you can just keep it as an improper fraction. If you want to put it as a mixed number, you can, or decimal, or you can just stop there. That's what y'all doing today. See why this is a little bit easier than dividing? Any questions? So the only hard thing is to remember you got to square both sides, and then you do the stuff that you can do in your sleep. All right, examples, page 472.
Are we allowed to make that a decimal?
Of course. Yeah, I'm not going to tell you no. Of course you can. Okay, y'all ready?
Roger, Dodger,
Page 472.
Just can't actually call you Dodger.
I don't know. I ignore. All right, Michael. Number 1. Square root of x equals 4. What do I do?
What is it? Exponent?
You put it in an exponent?
No, the x.
What am I doing? Go back to your steps.
Yeah, wait.
Is this radical sign isolated?
Yeah.
So what was the next step?
No, you square it. That's
Square
the,
what?
The x. No, the whole thing.
So both sides. not just the x, right? But both sides, right? Okay, so, and you're writing everything I write. We're squaring both sides. So then, Michael, what do I get?
You get x is equal to 16.
And you're correct. Now, you can go back and check. If you got x equals 16, go back up here. Replace that x with 16. What is the square root of 16? And that checks. See, so you really can't get anything besides a 100 if you can go back and check it.
If you know, like, if you already know, like, the square roots, right, couldn't, like, if, for example, like, those problems, like, the ones, whatever, like, x equals 4 or whatever, couldn't you just already know the answer?
Yeah, but that's problem number 1.
Well, yeah, but, like, even if they
The rest aren't going to be like that.
number 2 is like that.
Well, let's look at number 3. Gabby, square root of x plus 2 equals 8. So first question, step 1 is isolate the radical. Is it isolated? Okay, so then tell me what to do. That's right. Square both sides. And then you tell me what I get. Okay, now what do I do? And you get, yep. Now, if you want to go back and check, this says x equals 62. You go back over here. You put 62 plus 2 equals 8. 62 plus 2 is 64. The square root of 64 is in fact 8. So it checks. So that's what I mean by if you actually take the time to check your work, you can't possibly get it wrong. Any questions? Does everyone have it down? All right, let's do another. All right, number 11. Number 11's weird. I'm putting a star by it. All right, let's look at it. I'm going to do this one. 2 minus square root of x equals negative 8. Okay, is this radical isolated? Is it all by itself? No, it's not. So then we need to move this 2 out of there. Emily, what sign is that 2? So then the opposite is, there you go. So we're going to subtract 2 on both sides. Now pay very close attention to that negative sign. We're going to rewrite our problem with that negative sign. Equals negative 10. Okay, think back to the rules on variables. Can I have a negative variable? No. So can I have a negative radical? No. Think back to what do we do when our variable is negative? What do we do? Yep. So then that changes. So now we have positive 10. So be very careful when you have those negatives there. When you're isolating the variable, it's got to be applied over here, just like we do when it's a letter. Now what do I do, Michaela?
Square both sides.
That's right. We're going to square both sides. And Michaela, what do I get?
X equals 100.
Perfect. Any questions? No questions? All right. Cecilia, 13. 7 plus 3 times the square or the radical of x minus 3 equals negative 14. All right, Cicely, what do we do first? What do you think we do first?
7 plus 3.
Well, this is being multiplied. The 7's all by itself, but we're doing intruder alert because we're trying to isolate this radical. So what do I need to move first, the 7 or the 3?
7.
That's right. Think back to when we do regular intruder alert. She's correct. So how do I move the 7 first? I'm gonna write first. We move this guy, just like intruder alert, we move it first. And she's right, we're subtracting it. And I get 3 times square root of x minus 3 equals what, Cicely?
Negative 21.
Perfect. Now, what do I do? Because this still isn't isolated because I have this 3 out here.
Subtract the 3.
What operation is taking place?
Divide the 3.
Okay, this 3, boys and girls, is being multiplied with that radical, so we're going to divide by 3. And I get the square root of x minus 3 equals what?
Negative 7. Not real.
Everyone, round of applause for Cecilia. Yes, I'm so happy you caught that. She isolated the radical. She did all that work, got it down to where she isolated it all by itself. And oh, look, this is a negative. No. So she's correct. We can say, what does your book want you to say? No solution. Good catch, Cecilia. Good job.
I did the problem wrong, and still got no solution.
Yes,
What if a problem has more than one radical?
more than one radical.
Yeah.
Well, then we're about to do one. Actually, Taylor's going to be doing one in a minute.
If there's a plus sign, if you just
Okay.
put them both on the same line.
Does anyone have questions about this? All right, Emily, you ready for the challenge? Yes, you are. 15. It's similar to what Cicely did. 5 plus 2 times the square root of y minus 3 equals 27. All right, Emily, what do we do first?
Subtract the 5.
Yep, subtract the 5 on both sides. Because we always do the guy out there first. And we get 2 times the square root of y minus 3 equals what?
Okay.
Yep, good. Now what do I do?
Divide the 2.
That's right, because we got to get rid of this 2 to isolate the radical. It's being multiplied with that, so we're going to divide by 2. And I get the square root of y minus 3 equals what?
11.
All right, now we've isolated the radical. Emily, is this negative?
No.
So then we can move on. So what's the next step?
You square everything.
You square everything. And what do you get? Okay.
Equal 121.
Yep. Very good. Now what do I do? You add 3 to both sides. And I get y equals what?
124.
And there's your answer. Any questions? All right, I saved the hard one for Taylor because that's what you wanted. Look at number 20. I have 5 times the square root of x minus 13 equals 2 times the square root of x plus 26.
So,
My advice, treat the radicals like you would in everything you've done as a variable. But when you're adding and subtracting, remember the rules of adding and subtracting radicals. All right, go ahead.
so, first you take negative 13, put it on the other side, make,
How would you do that?
subtract both sides. Yeah, no, yeah, we'll add both sides.
Okay. And I'm left with 5 times the square root of x equals 2 times square root of x plus what?
39.
39. Okay, so I want y'all to notice he went ahead because we're trying to get the radical on one side of the equal sign and all the numbers on the other. And he did that. He first moved the 13 over there. All right, now what?
Now, you do, yep, you subtract both sides by 2 times the square root of x.
That's right. So we're going to look at this. Now, all y'all look. We treat this kind of like a variable, like we've been doing. So we're going to subtract on both sides because we got to move it over here. Now, Taylor, can we add or subtract these two? Why?
Because they have the same root.
They have the same radicand. Yes, because this has the same, we're following the rules of adding and subtracting radicals. He can go ahead and subtract. So what do you get?
3 times the square root of x.
Yep, equals 39. See that? So he's treating this as like one whole variable. It's positive, so he subtracted it on both sides. He can successfully subtract this because the radicand is the same. And you get 5 minus 2 is 3, and the radicand stays the way it is. Now what do I do?
Now you divide both sides by 3.
Now what do I do?
Now it's not negative, so you can move on.
It's not negative. Now he has successfully isolated the radical. This is not negative, so you can move on. What do I do?
So now you square both sides.
I'm going to go ahead and do this here. And what do you get?
And you get x equals 169.
And he is correct. Any questions? Yes.
What if they don't have the same radicand?
If they did not, that's a good question. If this did not have the same radicand, let's say it was maybe like 2x, then you'd move it over here and it'd be 5 times the square root of x minus 2 times the square root of 2x.
That'd be no solution.
No. It would be harder to do, but it wouldn't be no solution.
Yeah, because you could move the 5 and the 2. Oh, it'd be messed. They won't give you a problem like that, but then you would square both sides, and then you'd keep working. It'd be weird. They're not going to do that to you. Yes. All right. Any questions? Hopefully you sat back and looked at this.
9.
Page 472. Numbers. Yes. You want it? You ready to do it?
It flattened all the.
Okay, you can sit back there.
Okay.
Or you can sit back there if you want. Okay, so numbers 2 through 18 even. Honors. Let's see. Hold on. Four through 18 even, and what do I want to do? $32. These are due Thursday. You have a test Monday.